Hello, Natalie Tarry here from Natematics, here to take you through how to find the highest common factor and the lowest common multiple. I will let you know that I have a little face down here. I'm going to share my daughter. So yes, this is my dear daughter, Caris, who wants to sit and play pull faces at me as I'm recording it, bless her. Anyway, I'm going to record. I'm human, and this is what is going on behind the scenes. Anyway, so definitions: highest common factor, lowest common multiple. Well, what I'm going to do, without showing you using Venn diagrams and prime factor trees, is just a little reminder of what are those things. So the highest common factor, as always, I like to show these things using an example. So find the highest common factor of 24 and 32. Now, if you've come to watch this lesson, hopefully you'll have also looked at, well, what is a factor and what is a multiple? But just a reminder, a factor it's a number that divides without a remainder into the other number, okay? So a factor of 7 would be 7 and 1. If you divide 7 by each of those numbers, you do not have a remainder, okay? Right, so looking at 24 then, what we're going to do is I'm going to give you a nice little easy way of finding the factors and making sure that you include all the factors. So all these numbers are going to have 1 as a factor. So then we think, well, actually 1 times what would make 24? 24. So 24 is also a factor. So what we have here is what we call a factor pair. Right, so then 2. Now 24 is an even number. So we know that 2 is going to be a factor because an even number has 2 as a factor. So 2 times what makes 24? 12. And just another little bit of maths learning here. Well, look at what's happened to these numbers here. It's gone from 1 to 2. Thinking about either multiplying or dividing, sort of multiplicative relationship, what's happened to go from 1 to 2? It's doubled, times by 2. So therefore, if we're doubling one of the numbers, the other factor we must divide by 2 to still end up with 24. Look at numbers. When you do things like this, look at them and see if you can work out any little patterns. I always find that's quite a useful way for students to kind of get more confident with numbers. Right, anyway, back to highest common factor. So 3, is 3 a factor of 24? Well, guess what? If you know your times tables, you will know it is. But I'm also going to give you another little tip. So 2, you've got the digits 2 and 4, 24. If you do 2 plus 4, you get 6. Is 6 a multiple of 3? Yes. So therefore, 3 is definitely a factor of 24. It's a good way to find it. So anyway, 3 times what makes 24? It is 8. And we can go down, we'll say, well, next number after 3 is 4. 4 times what makes it 24? It's 6. Then, okay, next number would be 5. Well, it doesn't end in a 0 or a 5, so 5 isn't a factor. And then we get to 6. Well, I've already covered that here. That's where we stop. And that's why having those two number lists is a really useful way to help you make sure you include all your factors. Okay, so we're now going to repeat that same process for the number 32. And again, I've done exactly the same thing there. So what is the factor? That number times what makes 32. So we've got 1, 2, 4, 8, 16, 32. So then what we've got to do is we're going to highlight the common factors, because again, we've sort of done the factor bit. Now we need to do the common bits. And again, remembering with the English and in maths has literacy in it, and it's making sure you remember what those words mean. Common means the same. Okay, so let's go down these lists and let's find the ones that are the same. So they've both got 1, they've both got 2, they've both got 4, and they've both got 8. Now, select the largest one, because that's the next one, isn't it? It's the highest. So we've got the factor, we've done the common bit, now we're doing the highest one. There we are, it's 8. So out of 1, 2, 4, and 8, the highest one is the 8. So the highest common factor, or HCF, as we abbreviate to, is 8. Okay, now we're going to do the lowest common multiple. So find the lowest common multiple of 24 and 32. multiple. If you're always trying to think, if you can see the difference between the two, I thought she has disappeared from behind me. The factor of a number is either as big as the number or smaller. A multiple is as big as that number or bigger. Okay, so the multiples are things like in your times tables, your 4 times tables. So your answers, so things like 4 times table, you've got 4, 8, 12, 16, 20, 24, etc., etc. Those are the numbers that are the multiples of 4. Okay, so you're multiplying 4 by 1 and 2 and 3 and a million, etc., etc. But we're not going to get into that now. So what are the multiples of 24 then? Now we can just write them down there. And we do exactly the same for 32. Okay, now when I did this, I actually purposely did it without a calculator. And what I did was I said, well, okay, so that's 24 here. And I added another 24 and I got 48. I then did another 24 underneath to get the 72. And then I added another 24 underneath that to get the 96, etc., etc. Okay, so now we've got the multiples. Highlight the common multiples, the ones that are the same. So then we've got 96. Now I could have carried on. When you've got smaller numbers, maybe like the lowest common multiple of something like maybe 4 or 7 or something, you're going to have more common multiples coming through. Here, I wasn't going to do all the big numbers per se, okay? Because to be honest with you, there's a much better method of doing this, as you'll see when we're coming on now. So highlighting the common ones, and here, the lowest one is, there's only one on here now. So the lowest common multiple, LCM, of 24, and 32 is 96. Okay, so let's show you the other method. Now, I'm just thinking now, did I check this before I am recording it? So if I have to edit something in, I will do later. Okay, so what we're going to do now is we're going to use the Venn diagram to share with you. If you haven't done Venn diagrams or you've not done them for a while, maybe go back to find the link to the Venn diagram lesson. And I'm saying that now because I am in the middle of populating a big spreadsheet with all different videos on and stuff. But I will kind of go over a bit of Venn diagrams in this lesson. Anyway, so what we're doing is express both 24 and 32 as a product of their prime factors. So that's the first thing we've got to do. You wouldn't, in some questions, it might ask you to do this, and then it might say, subsequently, what are the highest common factors and the lowest common multiples of those numbers? Okay, so we're going to go through that same process again. So numbers that multiply to give 24, 2 and 12. Is it a prime number? Yes. Circle it. If it's not, carry on down the branches. So we've got 12 goes into 2 and 6, and 6 is 3 and 2. Doesn't matter which way around those go at all. Okay, I asked you earlier on if you do those, in the prime factor lesson, which I've just recorded and I've remembered is a separate lesson, I said, what happens if you do them in a slightly different order? So maybe instead of doing 2 and 12, you do, like, say 3 and 8. Oh, do I get a different answer? No, you don't. You just have a different shape tree. Okay, so we can say that 24 is equal to 3 times 2 to the power 3. Notice I've given that an index form there. All right, so 32 is 8 times 4. No prime numbers there, so we carry on. And then we stop when we have prime numbers and we circle them. Okay, and again, if you need some help with that, go and have a look at the prime factor tree and prime factor lesson. So here we have lots of different size circles, but that's okay. We have 32 is equal to, and there's 5 lots of 2 multiplied together. So 2 to the power of 5. Okay, so all I've done there is just sort of taken it to the other side, and I've said the bits that we really need now are those, the decomposition, what it looks like as in index form. So 24 is 3 times 2 to the power 3. So just a quick reminder then, create a Venn diagram. So we've got 2 sets going on here. We've got the factors of, prime factors of 24. The other one is the prime factors of 32. Just a reminder, what does this mean in the middle? So if we've got 24 one side, 32 the other, the middle must be prime factors that are common for 24 and 32. Okay, so what do? Now you'll notice here that I've split it out into the individual numbers. Now, yes, that's exactly as what's above here. But I find that when you're checking off numbers, it's easier to have them when you've split them out individually. So 2 times 2 times 2 times 2 times 2. Yeah. So let's pick one. And what we do is we just look for a common one, circle it, and then that will go in the middle. We only put one of those in the middle because it's common for both. Then, have we got any more common ones? Yeah, I can see there's definitely another common 2 for them. So that will go there. And there's another common 2. So that'll go in the middle. So now, well, I've got a 3 here, but that hasn't got a 3. And we've got 2 more 2s here. That doesn't have any more 2s. So now we're going to go into, well, here is the prime factors of 24 that are not also a prime factor of 32. Okay. So where we've got 3 will go on the left-hand side. And then we've got 2 2s, which will go in the right-hand side there. So what we're doing is splitting those individual prime factors into the different sets. Remember, and I'm going to emphasize this again, it's really important that when you have, even though you've got, some people might say, well, 3 is a prime factor of 24 and so is 2. But it also has 3 of those 2s to make the 24. So each one of those must be featured either in this side or in the middle. Okay, so when you isolate just the 24, you've got 3 and 3 2s. A 3 and 3 2s. When we look on the other side, and again, just a bit of Venn diagram revision, you've got 3 lots of 2 and another 2 lots of 2, which makes 5 altogether. Again, good check for you. I have done a really, really interactive lesson where I've coloured different sections of the a Venn diagram, and I did like a 3-way Venn diagram. Have a look for that at some point. Again, once I've got my spreadsheet set up with all my lessons in, so it's a really good lesson. And it really has helped a lot of students. Okay, so back to this example then, we're nearly kind of at the end. So I've asked for the highest common factor and the lowest common multiple, okay? Now, the one in the middle is still going to be the lowest one. So that's the common factor, but it's the lowest common factor, okay? And you think about when you have a fraction, say you have 6/8. 6/8 is the same as 3/4, isn't it? So in terms of its size and what it represents, they're the same. All we're doing is dividing by a factor of 2, let me remember to do in my head, to be able to get it in a slightly different form and get it into a lower numbered fraction. Okay, it's in its lowest terms. So that's what we're doing here. We're just taking out the 3, we're taking out the other 2s, and the common ones are 2 times 2 times 2, which is 8. When we did this the long method, didn't we get 8 then? Now I must admit, this bit is not that, doesn't take that long to do. But the highest common multiple can take a while. So if we can find a method using this, it's quite handy. The highest common factor, sorry, that's the highest common factor. The lowest common multiple. Now I'm just thinking now. Oh no, it's fine. No, this is where I end up kind of getting a bit confused myself when I'm trying to explain things. So a multiple and factor. You've got multiple always tends to be the biggest number, whereas the factor tends to be a smaller number. But then you've got the confusion of it's the highest and it's the factor. It's the highest of the common factors, which is obviously the lower, which is a lower number. The factors are a lower number. Just be careful there. I just suddenly thought, have I written something down wrong? I haven't at all. Right then, the lowest common multiple is literally multiplying all of those numbers together. So 3 times 2 times 2 times 2 times 2 times 2. How is that different from me just saying, well, 3 times 2 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 times 2? How is that different? Remember, we need the lowest common multiple. Okay, so if you were to multiply 3 by each of those numbers, or each of these numbers, 3, 2, 2, 2, and then 2 and 5 lots of 2, you're going to get a much bigger number. If you divide it down by the 3 and the 2 and the 2, you're going to get 2. Sorry, not the 2, 2, 2. Divide it by 8, you're going to get the lowest common multiple. Okay, so if you want to have a little play around, fine, but this, what I'm doing here is giving you a clear method to do. So highest common factor is the numbers in the middle. The lowest common multiple is the 3 times 2 times 2 times 2 times the 2 times the 2. So it's multiplying all of those numbers together. And guess what? Wasn't it 96 that we had when we circled the numbers? We found all the multiples. Okay, so it's always remembering the lowest common multiple is multiplying them all together. The highest common factor is the one that's in the middle. And you're always going to get a smaller answer for your highest common factor than you are for your lowest common multiple. Even though it's the lowest, again, this is where you've just got to be careful. Make a note. Multiple, higher. Factor will be lower. Okay, and I think that is definitely the last one. So I'm going to stop sharing, and there will be quite a few more videos I'm going to be recording for you, and they're going to be in like a big spreadsheet. It's like Hegarty Maths revision sheets, and he's got all those links to the different videos. It's what Natematics is in the middle of creating right now. Okay, so I am actually going to leave these 2 videos I've recorded today, and I'm going to put them on public access, and I will be recording a higher level one as well, so people can see what I do. But the rest of them are going to be only available with my maths club. If you want to be in my maths club, if you want to have videos of everything on the whole maths GCSE syllabus, you need to be in maths club. £15 a week. You get a masterclass every week. You get access to me every day on a closed forum, which will be Discord and Facebook. And I will create things for you as requested. And I'll be covering lots of other things as well. So I might be looking at maths anxiety, just exam practice full stop, problem solving, all of those sorts of things. So please come along, message me at info@natematics.co.uk. and we will get the information sent to you and getting you in there, because guess what? Why not prepare in the best way that you can for your GCSEs, so you don't have to do them next year? All right. Thank you for watching, and tell more people about me as well. So if you like what you see, leave a comment, share it, save it, what have you. Take care. Bye-bye.